Okay, we're going to take a little bit of time to look at some linear programming. That's going to be taking a system of inequalities, which would be our constraints, and then an equation that represents cost or profit or anything that is going to have certain limitations on it and a certain value for that. So the purpose of this is finding what the maximum or what the minimum of something would be. So as we look at the steps, we're going to graph a system of inequalities first, then find the corners, and then whatever those corners are, because one of those corners will end up being a maximum, another will be a minimum. Plug those in to this main formula for the quantity to find our maximums and minimums. So, looking at this, I've got, for my first problem, the objective quantity going to be c equals 4x plus 5. For my constraints, I have x is greater than or equal to 0, y is greater than or equal to 0, and then x plus y is less than or equal to 6. So, first thing I need to do is, I know the graph of these two lines without any problem, but I need to either find the x and y intercepts for this line, or turn it into the y-intercept. So if you turned it into the y-intercept, you'd end up with y equals negative x plus 6, and you could graph it from there. Or if I find the intercepts, when I put x is equal to 0, means y is 6. When I make y equal to 0, means x is 6. So, doing a little bit of setup, first thing I want to do is get my graph over here how it needs to be. So, since I'm only going up to 6, I can use my ruler, and I'll just mark every centimeter. That way it keeps it nice and even. And I'll do that going up as well. And I'll label. Remembering this is my x-axis. And that's my y there. Okay, so I know that for my x being greater than or equal to 0, that means any x value I have is going to be over and above this. So starting at the y-axis and going this way, y value greater than or equal to 0, anything going up this way. So those are just basically putting my two axes as constraints, so I'm not going down anywhere into the negatives. Next, I'm going to graph this x plus y is less than or equal to 6 line. So, got my 2 points there, and it's less than or equal to, so I'm just going to draw a straight solid line. That should give me what I need. And with that one, it says that those are less than or equal to 6. I can check real quick to make sure, but if I put both of those as 0, that would say 0 is less than or equal to 6, which is true. So it is going down this way. So that means I'm going to be dealing with anything in here. So that means any values in here are possibilities that I could get for within the constraints that I have. And now I need to look and find my 3 corners. So we'll label those. My first one down here is 0, 0. Next one I've got is right here at 6, 0. And the final one up here would be 0, 6. So to test those out, I'm going to have to find the corners. So I'll just make a little, or I'll test out the corners using my formula rather. Make a little chart here. And then corners. Then my formula, which is 4x plus 5y, and that'll be equal to c. Now, notice we haven't used this formula at all in making our chart, so we are using it now for the first time to find our maximum and minimum here. So my three different corners would be the origin, 0, 0. Then I have 6, 0 and 0, 6. So looking at these, all I'm going to do is plug in these numbers to the formula. So 4 times 0 plus 5 times 0 would just give me 0. For my next one, I have 4 times 6 plus 5 times 0. That would give me 24. And for my last one, 4 times 0 plus 5 times 6 would give me 30. So, since those are my only three points, those are the only ones that I have an opportunity to be a maximum or minimum. I could choose some points in here. For instance, if I chose the point like 3, 3 here, which would be on that line, and I put that in, it'd be 12 plus 15, so 28, so not quite to 30, but it's getting closer to that. Somewhere in between those two, just like that point would be somewhere in between those lines. So, looking at this, for my corners, the minimum value of c would be 0 when x equals 0 and y equals 0. The maximum value of c is 30, and that's when x equals 0 and y equals 6. So for this particular equation here, if you were looking at selling two different items and the cost it takes to make them versus how much you would make, whichever this item is that was making $5 a piece, you'd say it'd just be more beneficial if you're trying to make the most money to, instead of trying to make some of the other thing that was cheaper, just make all of the more expensive thing, and you're going to end up making the most profit. We'll look some more at questions like this. I'll probably post another video going over one of the other problems for the notes, just so we get a feel of kind of how this works for our linear programming.